Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy, and if you need to get a hold of us, you can call 636-4357 or toll free 1-866-636-6284. You can email us at dothemath@kern.org or watch us online at dothemathonline.net and look for us on social media as well.
All
Facebook,
right.
Instagram, Twitter, YouTube.
That's it. And you have all of those, right?
No.
Oh, okay. I don't have any of those things. Well,
No.
you know what? I'm involved with them because of the program,
Yes.
but I don't personally have all of that stuff. Anyway, nobody cares about that. Hey, we do have phone tutors available until 5:30 this afternoon. A little programming note, because today is the 14th, I believe, correct, right?
Yes.
All right, so today is the 14th of November. No live programming next week on the 20th and 21st due to the Thanksgiving holiday. So there will still be programs being aired, but they will not be live programs next week due to the Thanksgiving holiday. We have a very special guest in studio, and we will meet that young man in a little bit. We also have a contest going on with two schools over in San Luis Obispo County. And here's a little graphic with the two schools. And they have been competing since September, and they have a couple of weeks left. Actually, I think the first week of December will be the end of that contest. So they've got about a little more than 2 weeks to keep going on that, because the winning school will have an opportunity to go over to Doc Bernstein's ice cream lab and have a couple of their students tour the lab, get all the behind the scenes things on how the ice cream is made. And Doc Bernstein's is big over on the Central Coast. Have you ever been
No.
to Doc? All right, the next time you go to the Central Coast, go to a Doc Bernstein's. I think there's like 3 or 4 of those things over there. And just try some of the ice cream. It's outstanding.
Awesome.
And one of the students over there will have the opportunity to win a golden ticket. And the golden ticket is an opportunity to get an ice cream sundae every month for an entire year.
Nice.
Simply by calling Do the Math. Not a bad deal. Also, do remember the emails. So there are some students that email us, and you want to try to do that on a Monday or Tuesday, or at the latest on a Wednesday. And there was a student that said, I have a problem in Algebra 1. Can you help me out? You need to email the problem to us also at the same time, okay? So we'll be more than happy to help you out, but just email the specific problem, and then we can help you out with that as well. We'll be going out to a local farmer. I've been waiting a long time to have a farmer on the program and talk to us about how they use math out there. We'll visit with Mr. Kirschenman in a little bit. But first, let's take a look at today's Math in the News. So yesterday we were talking about some different number puzzles that come in the newspapers and things like that. So do you get a Sunday newspaper?
Yes.
Okay, so you obviously get the Parade magazine. And in the Parade
Yes.
magazine, in the Sunday newspaper, there's usually a number puzzle of some sort in there every week, and that's the one we were looking at yesterday. Well, there are other publications that come in the mail, and this is another one that I found. And what they want you to do is figure out the numbers that go in here, and they need to equal up to the numbers at the end of the rows and at the end of the columns. So that we can see right now that we have equal to 15, we already have a 6 and a 4. So we know that that already adds up to 10. But we now know also that we need 5. So there's some different ways that we can do this. And if I'm not mistaken, you cannot, it's kind of like the Sudoku thing, where you can't put the same number in the same row and same column like that. So we know that we can get 5 by adding a 4 and a 1. But if we already have a 4 and a 1, the only thing would be a 2 and a 3. That's the way I approached it the first time, and it doesn't work.
Oh,
So you can repeat numbers,
okay.
all right? And instead of having me do it, because I've already kind of gone through it, I'm going to have you do it.
Oh, no.
I'm only kidding. Come on up here, Haydn, real quick, because we're going to have our guest help
All
us out with
right.
this one right now. So before we get started, let's find out who this is. Haydn, how are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary, and I'm in 6th grade.
All right, good. So that's what we need to know right now. You now need to get to work, all right? So take a look at the monitor underneath right there, and it'll be up on the big screen also, all right? Now, we know that this has to equal 15, right? We have the 6 and the 4, so we know that that equals 10, all right? So the other two numbers have to add up to 5, all right? And if you remember, I just said using a 2 and a 3 will not work. So what numbers do we have to use?
4 and a 1.
Okay, so where would you like to put the 4 and where would you like to put the 1?
The 4 right next to the Z.
So you want to put the 4 here
Yes.
and the 1 here?
Yes.
All right. So that works. So now we have 15 here. So now, what row or column would you like to work on next?
RTWZ.
Okay, so you want to come down.
Yes.
So you know that we need a 14 and we already have 4. So out of the 3 numbers there, how many do we need? It needs to
10.
add up to 10, right?
Yeah.
Okay. So what would you like to go with?
2, 3, and 5.
Straight down 2, 3, 5?
Yes.
Okay, so we'll go 2, 3, 5. Now that satisfies that, correctly?
Yes.
Okay. So where would you like to go to now?
U, Y, Z, X.
Okay, so we know we need 20. We've already got how many?
10.
So obviously we need 10 more,
Yes.
right? And what two numbers would you like to go with to make 10?
7 and 3.
Where would you like the 7?
U.
So U7,
Yes.
Z3?
Yes.
Okay, that works. Now, I know you can go anywhere you want, but I would say let's take a look at this since we'll only have one number left to get to 24. So far we've got 2, and 7 is 9, and 4 is 13. So how many more do we need?
11.
None of these have 2 digits in them. So we can't use an 11. So we knew this worked and this worked, right? So here I think what you did is you went 2, 3, 5. You need a larger number up here. So what would you like to move around?
Put the 5 where the 2 is, and the 2 is where the 5 is.
All right, so let's do that. So we'll put the 5 up here and the 2 right there. So now let's take a look. We have 5 and 7 is 12 and 4 is 16. What do we need?
8.
8. Okay, so we'll put the 8 there. So let's make sure that this still works, right? So we have 5 and 3 is 8, and 2 is 10, and 4 is 14. Works. Let's go across. 4 and 4 is 8, 9 and 6 is 15. Works. 5 and 7 is 12, another 12 makes 24. This, let's take a look at this, right? 7, 13, 16, 20, it works. So we've only got a little bit to fill in. Where do you want to go?
X, U, S, W.
Okay, so we have 4 blank blank 1. So we have 5, and we need 13 more.
6 and 7.
6 and 7? You want to go 6 here and 7 here, or which way you want to do it?
Other way around.
7 and then 6?
Yes.
Okay. Is there a reason you chose to put 7 up there instead of down here?
Because if you go the row, then it equals 16.
Right, and we need to get to 23, which is going to be higher than 11, right? So you're going to need a larger number here, right?
Yeah.
So if we have 13, 16, what else do we need?
7.
7. Now, taking a quick look, 8 and 7 is 15 and 6 is 21, and we still have a blank.
0.
None of them will be 0, all right? So we don't want a 7 here, right?
Yeah.
All right, so let's get rid of that. So you don't want something as large as that number, right? But you kind of get the idea on how this works? All right, well, you know what? We'll let you finish that up in a little while. But that is today's Math in the News. Always a lot of different publications with problems in them. Have you guys ever seen anything come in the mail or newspaper or things like that where there are number games?
Sudoku.
Oh, see, that's in the newspaper all the time, right? It's in a lot of magazines also. There are websites for that. And are you pretty good at that game? Have you played it a lot?
Sometimes.
Sometimes?
Yeah.
Do you do the most difficult ones or do you do the easy ones?
I do the most difficult.
The most difficult ones? Good. Well, you know what? We're going to have you do some difficult math problems in just a couple of minutes, all right? But what we're going to do right now is we're going to go out live. We have Kirschenman Farms, and we're going to go out and visit with Wade and Scott.
Hey, thanks, Mike. We're here again, math in the real world. We're live here at Kirschenman Enterprises. We want to know a little bit. I mean, it wouldn't be a true math show if we didn't figure out how math figures into agriculture. The whole entire county seems like we're wrapped up in agriculture and oil. So today we're going to look a little bit about how math works in agriculture. And we have the president here, Wade Kirschenman. Thanks for the time. Appreciate you being with us today.
Good to be here.
Tell us where we are and what's going on here.
Well, we're out at our company's farm in Lamont, California, I guess technically. And my father and I have been running the farm for, actually grandfather started in the 1939, so we've been out here a long time. And we're going to show you some table grape packing right now, what we're doing. It's late in the year and we are getting close to being done for the season, but here we are, we're packing some late season grapes. And,
right, it does seem kind of late in the season. I mean, I usually think of grapes as like a summer crop, but these ones have been kind of held over a little bit. How do you get them to ripen up so late in the season? That's got to be a special technique, right?
Well, these are later varieties that we have. These are different varieties than what you would buy in the stores in July or even August.
Okay.
And so they're made to ripen later in the season, and you know, we hope they can stay fresh until the season's over. And in the wintertime, most of the grapes that you buy are from Peru and Chile, but these are the late season California grapes. We're still going, and so they're we try to keep them on the vine. We put rain covers on, and
right. So you have some specific methods that you use to make sure that they're fresh all the way through. So if you're still buying grapes at the grocery store, they could still be from California at this time.
They are from California, right?
Okay.
Right.
Good deal.
Right.
What other kinds of crops do you grow in your business?
So we grow potatoes is a big crop for us, one of our main crops. We grow watermelons, peaches and nectarines early in the season, carrots, peppers, cannery tomatoes, almonds, oranges, all kinds of stuff.
And the climate here in Kern County is so unique, right? We were talking about that a little bit earlier, about the fact that you can grow so many things in this area that you couldn't grow in other areas. Whether you go east of here, whether you go north of here, or even south of here, Kern County really has a unique climate. Tell us what exactly makes this place so unique.
We're in a very unique area. We have a long, a dry summer that doesn't have a lot of humidity, which is good, and we don't get a lot of rain, which obviously we do need some rain, but we don't want it in the middle of the summer. But there are several crops such as table grapes that are, specifically just grown between here and say Madera, which is just north of Fresno, and you really can't grow them anywhere else in North America because of you can grow wine grapes in Oregon or Washington, but not really table grapes because of the cooler weather.
So the main component is the weather, right? What about the soil? Anything special about the soil in Kern County?
The soil types, we have deep soils and that are sandy loam soils that are really good for growing these crops, and we do have a lot of water issues in front of us, but we are blessed to have generally, historically speaking, good snowpack. So we do have groundwater and good water here, although we do need rain.
So water's always an issue for farmers, right? Where does the majority of the water come from on your farm?
The water, we get, half of our water comes from wells that we have in the ground, and the wells are, the aquifers are generated from the snowpack in the mountains. And we also get water from Northern California through some of the various canal systems that we have in the state. So water's obviously a a big issue. But as farmers, we feel like we're not wasting water. We're using water to grow food. So,
Right. And a little bit, if you don't mind me asking a little bit about the irrigation process, that's changed over the years too, right? Because there used to be flood irrigation where some people might look at a field and say, wow, that really is wasting water. There's water everywhere all over that field. And now we have drip irrigation. Of course, there's some math that goes along with that, but how does that work? How does drip irrigation work, and why is it more effective?
the drip irrigation allows you to put the water right where you need it, right next to the plant's root system, and not 10 feet away or 20 feet away. The flood irrigation systems, used an excess amount of water that was really not necessary, and so we're able to just give that plant just what it needs for irrigation, and thereby saving a lot of water.
Right. And I'm sure that math had a lot to do with that, right? So we want to talk a little bit more about how the math goes into packing the grapes, about what's going on specifically in this facility, but we know there's also some math to do back in the studio. So we'll go back to Mike at this point. We'll be back in a bit to talk more about math in the grape fields.
All right, thanks for that, Scott, and also thank you to Wade and showing us around Kirschenman Enterprises out there. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Just a reminder, next week, due to the Thanksgiving holiday, no live programming. Right now, though, we'll go to the phones. And Rubie, how are you this afternoon? Hello, Rubie.
I'm good.
Good. You are a 6th grade student at heart, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. It's -3,
Whoops.
parentheses,
Hold on. Okay. -3 parentheses.
4x, -5, closing parentheses,
Okay.
-6, open parentheses, 7 minus 2x, closing parentheses.
And while you're doing that, we're going to have Haydn working on the same problem and see if you guys come up with the same thing. You ready?
Okay, is this the whole problem? It's not equal to anything, you're just having to simplify it?
Yes.
Okay. All right, so what do you think your first step is?
I think my first step is to get rid of the parentheses by doing -3 times a positive 4x,
Okay, and what does that equal?
-12x.
All right. Okay, what's next?
Then you would do -3 times -15,
Okay. And what do you get there?
positive 15.
Okay. Do you happen to remember the name of that property that tells you can do that? You can say no.
No.
Okay, that's the distributive property. Okay, go ahead. You got it so far.
Okay. Then to get rid of the other parentheses, you would do -6 times positive 7,
Okay.
which would equal -42.
Ah, my pen isn't working. Okay, -42.
And then to finish it off, you do -6 times -2x
Okay.
equal positive 12x.
All right, so now that we got rid of the parentheses, what's next?
Next is to combine the like terms.
All right.
So I would combine the numbers with an x, which is -12x, and positive 12x, which would cancel each other out.
Okay.
And then you just combine positive 15 with -42
Okay.
to equal -27.
All right.
And was there anything you had to do with that problem? Because I know sometimes you had homework where you had to look for an error or if it was done correctly. So was there anything you had to do on that problem?
Yes, you had to see. So there's someone did the problem, and then either they do it incorrectly or they did it correctly. And if they did it incorrectly, you would write wrong.
So was this problem done correctly before or not?
It was not.
It was not. So you know what? If you have a moment, why don't you read to us what was on the paper? And maybe you can just grab the red marker, Cindy, and do
All
it
right.
in the other color so we can see what was on the problem. So go ahead and read what was on the paper before.
So it was the -3 parentheses.
So
For
the same
X.
problem, right?
Yeah.
Okay, I'll write that down. -6 parentheses 7. Okay, got it.
But then they did their first line as 12x, +15, -42, and +12. So the same as my line.
So -42, +12x. So just to make sure, you said for theirs they did +12x, +15, -42, and +12x?
Yes.
Okay.
So they didn't have a negative symbol
they
at the first 12x?
They had the negative as their first 12x.
Okay.
Oh, they did? Okay. Got it. Okay, so so far it was the same as yours. Okay, so what'd they do next?
They crossed out the 12x's
Okay.
because they would cancel each other out. But what they did was they did 15 plus 42 instead of doing the difference.
Okay.
And then taking the one that was bigger with their sign.
So they had 57?
Yes.
Or, yeah, 57?
They had -57.
Oh, -57. Okay, so they knew to put the negative, but they accidentally added instead of subtracting for the value.
Yes.
Okay.
All right, there you go. So that's what they did wrong. So nicely done with that error analysis. And for doing that, we're going to send you to a game courtesy of our friends at the Bakersfield Condor. So congratulations on that. All right, young man, you have a choice of problems to do. I'm going to give you a couple of numbers and you choose. 1, 2, 3, or 6, 7, 8.
6, 7, 8.
So out of 6, 7, 8, which one would you like to do? 6, 7, or 8?
7.
7? Excellent. Over to the board and I'll highlight number 7 and we'll see exactly what you have to do. All right. Find the percent of decrease. All right, so you and Cindy are going to work on this together. Find the percent of decrease from 270 to 190.
Okay.
Round to the nearest tenth if necessary. So you're going from
From
270 to
270.
190.
Whoops, I changed colors. To
And you want to
190?
know the percent of decrease.
Have you learned this yet?
Not quite.
Not quite. Well, so if we got to find the percent of decrease, do we know what it decreased by yet?
80.
So how can we figure it out?
We can change both numbers to 100.
Okay, so you got the 100 because you're dealing with percents, right? So it's just basically saying it started at this and it ended at this. How much did it decrease by? Like, what can we do to figure out what it decreased by? What's the decrease? What does that mean? What does decrease mean?
Get lower.
Yeah, it got lower. So how
Smaller.
much did it get lower by? How much did it change by? What do you do to find a change?
80. Subtract.
So you need to figure out the decrease first. So go ahead and subtract it.
Oh, wait. So
So
80.
decreased by 80. All right, so now we know how much it decreased by, but they want us to find the percent that it decreased by. So when you work with your percents right now in 6th grade, right? You're in 6th grade. Do you guys do proportions? Or do you just set up an equation, or
We set up an
you
equation.
set up an equation? Okay. Because when we do these in 7th grade, so when you get there next year, we do proportions. So this part's 100. You know where that came from? Because percent, right? This is the percent, which is what we're trying to figure out. Have you ever seen a proportion? No? Okay. Then on this side, what you got to do is figure out what you're trying to find the percent. So you're trying to find the percent of decrease. So you're trying to figure out 80 out of what the original amount was, so what it started at. So you're basically trying to figure out 80, the decrease amount, out of 270 is what percent. So, okay, so you've never seen, okay, so to set it up as an equation, let's see. Well, let's see, so for an equation, you guys would do like 80 is what percent, that's what you're trying to figure out, of, which is multiplication, right?
Yes.
So really I should have put it the other way, but of 270. So that would be equation way. That's how you guys do it?
Yeah.
So what would you do to solve that then? And maybe I should like put this just so it looks like the right format that you're used to probably.
Yeah, we divide by 270,
Okay.
and that would equal x and 80.
Let me move it down.
Yeah.
Give you a little more room. Okay, before you do that, I'm going to help you out a little. So if you notice, like these both end in 0, could you simplify them down a little bit first?
Yeah.
Might make it easier to. That's fine.
We add a decimal. Let's see how many. So.
Probably,
Yeah, instead of
probably
going
getting too
over
close
to the
the
right,
edge,
Hayden,
yeah.
go over to your far left
Go this way.
and do a little work over there. That way you've got some more room.
27.
Well, mine changed colors magically, so yeah. Do you want me to move it up maybe, or move it down? It might be that it's like a certain spot that gets.
It's 26. And 0.
Let me move the screen down a little bit for you right there. We'll extend it.
Oh wait, we lost part
Yeah,
of it.
let me move it up a little
Whoop.
bit. There you go. Have
Well,
you got it?
We both were doing it. And
Okay.
then, where is he? Right there? Okay.
So.
Well, hold on. So your decimal is right here, and your 2 is over the 0, so it
Oh.
goes right there.
So.
Try 6.
Does it make you feel better that we use calculators when we do this in 7th grade? On this part, at least.
It probably will.
Okay, so while you're dividing, I know you still have more, but it said to round to the
Nearest
tenth?
10th.
Okay. So right now you got 0.296, but how do you make it into a percent? What do you have to do?
Well, since it's 100, you move it back.
Yeah, so go
twice.
ahead and move it now, just because you know you're going to have to, because that way we can just keep dividing until we have enough to round. Because you don't have to keep going and going and going, you just need enough to round. So you need one more number since that's the tens place, you need one more to tell you if you need to change the 6 or keep it.
So I don't even want you to work this out. I want you to do this mentally now to see if you have to round that 6 or not. Because what does the number have to be or higher to round something?
5 or more.
It has to be 5 or more, right? Do you think 27 is going to go into 85 times or more?
No, not really.
No, because that would be well over 100, right?
Yeah.
So you know the number after the 6 is going to be lower than 5. So you don't even have to work it out. So now tell Cindy what your answer is going to be.
It's going to be 29.6%.
Nice.
So go ahead and write that somewhere over on the left as the final answer.
Put your percent on the
And you
right-hand
know what? That's
side.
funny because
I
the
know,
student
I
yesterday
know.
put the percent on that
Dollar
side
signs
also.
go here, percent signs go here. I know, maybe that's how they're working with them nowadays. I don't know.
My grandpa called me German because I put it like that.
There we go, 29.6%. Nicely done. And for your effort today, we will be sending you home with a free pizza courtesy of our friends at Cubby's.
Yum.
Nicely done. You like pizza?
Yeah.
Who doesn't like pizza? What do you like as far as the topping?
Pepperoni, sausage, and ham.
Ooh, that's all good stuff right there. All right, well, you know what? We'll go out to Kirschenman Enterprises, do some more work, and get to some more phone calls, all right after this. Today we're at Midway School, home of the mighty Midway Tigers, and we're here to... Once again, we're at Midway School, and we've got some students from 5th and 6th grade. And this time we're going to be looking at some word problems and how they have a lot of different ways you can solve these. And we'll see if there's a best way, or at least the right way. We're going to make sure we get that. So when you're working on word problems, what are some different strategies in how you can solve them? Do you guys have any strategies where if you see a word problem, you go, oh, this is the first thing I want to do?
Try to change the words into numbers.
Okay. Change the words into numbers, right? Make everything a little bit more relatable. What else?
Try to figure out what operation you're going to do.
What operation you're going to do, right? Because you're looking at the problem and you're like, all right, so what are some basic operations you can choose from?
Addition, subtraction, multiplication, and division.
Right. So sometimes the wording will let you know, right? Because if the problem says at the end of it, what is the sum of all of these numbers? You need to know a little bit of math vocabulary, right? In order to know what they're even looking for. So if it says, what is the sum of all these numbers, what do you think you're going to be doing? You're going to be adding, right? If I said to you, I would like the product. Now, some people might go, well, I want the product. Are you talking about, you know, the paper? That's a product. But in math, what are we talking about as far as product?
Multiplication.
You're going to multiply, right? So you guys have to be familiar with the vocabulary of math in order to figure out word problems, what they're looking for, okay? Word problems, are you always able to kind of read it and then just do it in your head? What would you have to do?
Draw it out on scratch paper.
Maybe draw it out on scratch paper, all right? So that's what I'm trying to get at. So you're going to draw something out. So what can you draw out, or what are you writing?
The equation.
Okay, so you can write down an equation, okay? Are there times when you can draw things and make it a whole lot easier?
Yes.
Okay, what could you draw?
Like you could draw graphs.
Okay, so you could draw a graph, right? What kind of, there's a lot of different graphs, right? So what are some different types of graphs?
Like maybe like earlier line graphs
Okay, line graphs,
or like bar graphs.
bar graphs, pie graphs, right? What else could you do? Any other strategies you guys have had?
If you're adding, you could draw circles and then add, count them all up, and then if you're subtracting, just cross the ones some out.
Perfect, an excellent strategy right there, right? So you guys are coming up with a lot of great ideas, right? So you could also make T-charts, little tables and things like that, right? So all of these strategies are things you're going to want to do when you take a look at the word problem, because somebody might go, well, I'm going to make a graph of this type, and they can get the right answer. And somebody else might go, I don't know what you're doing. I'm going to make a table like this. So is any way better than the other way? As long as you get what? The right answer, okay? So what we want to do is, so we came up with a lot of different ideas, and here's the problem we're going to work on, all right? So you're all familiar with money, right? Everybody likes money, right? Okay, but see, I don't have a lot of money. That's why we're only dealing in coins today, all right? Pennies, nickels, and dimes, not even quarters or half dollars, all right? So here we go. You have the same numbers of, the same number of pennies, nickels, and dimes. The total amount is $1.44. How many of each coin do you have? So you have all three of those coins. You have pennies, nickels, and dimes. You have to include all of those. The total amount is $1.44. And you know there are the same number of coins for each denomination. Does that make sense to you guys? All right. So what I'd like you to do is in your group, separately, however you want to do it, you can start on your own and then work together and see what kinds of strategies you're coming up with and see if you guys can solve this problem. So you have three different types of coins, pennies, nickels, and dimes. It adds up to $1.44. You have the same number of each. How many of each do you have? And what we'll do next time is when we come back with the students from Midway School, we'll see if they have the correct answer and how they got it. And once again, a big thanks to the staff and students at Midway School. We had a wonderful time on our visit out there. As a matter of fact, we had an opportunity to go to 3 other schools today. They will be featured later on during this season. 636-4357 is the phone number. We have a couple of phone calls to get to. We need Haydn to do some more work, but first, we're going to go back out to Kirschenman Enterprises and visit with Scott.
Hey, thanks, Mike. We're back here at Kirschenman Enterprises, and we want to know a little bit about how they use math when they're packing these grapes. So, Wade, can you tell us a little bit before we go and see the actual process? What are the factors that go into packing grapes? We obviously have to know how much they weigh, right?
We have to know how much they weigh. So right now we're packing a 4-pound clamshell, and the grapes were all picked in the field by hand, and we picked the grapes in these loose plastic boxes. And then once they're brought into the cold storage, we'll then repack them into whatever package we're packing that day for the customer. It could be a bag, it could be a clamshell of different sizes, it could be another loose pack box. So that's kind of how we do it. And the grapes are all they're picked by hand and very delicately, and they're clean, and they're not washed. They're we want the grapes to have more of a natural. If I go.
Yeah, well, let's take a look at some of these things that they are packing here. Now, obviously, there's some when they come out of the field, the packers have to look a little bit at the fact that you have some product that is usable and you have some product that is not usable, right? So we have a little bit of waste that goes into it. But each of the people who are packing they have to have a scale in front of them, right? They have to weigh how much it is. So how much does one of these clamshells? As you say, it's 4 pounds?
These are about 4 pounds.
Okay.
Like you get a better shot of the scales, maybe.
Yeah.
I just know she didn't have the scale.
Right. They got a scale there, and they're gonna weigh them. They're gonna pack them up, right? And then looks like you got 4 boxes or 4 clamshells per box.
4 clamshells per box. Right. That's correct. And once the package, the clamshell is packed to the appropriate weight, and cleaned properly, it's then the clamshell's closed up. We seal it up like she's going to do right now.
And then different times of the year, you're going to pack different varieties, right?
Yes.
So that's where the little label comes on top, and then they're going to make sure that each one of them has what they need for the specific customer. Now, when a customer calls in and wants to buy grapes from you, right, can they specifically ask for what color, how big they are, what kind of packaging? Can they ask for all those things?
Of course, yep.
Okay.
And some customers like clamshells like this, some like bags. They're really all different types, and there are different grades of grapes as well. And so these would be ship, just ship domestic. I'm not sure exactly where these are going right now, but
Right.
these would be a
But there's so
domestic,
many factors here too. So I'm sure that you keep really tight control on, first of all, your quality control about what the quality looks like. But then secondly, the efficiency of your workers, right? So you pay your workers an hourly wage, and so here's some more math that has to go into it. You want to make sure you get the maximum production out of those workers.
That's correct.
And so you get reports during the day, and they tell you some information. What are some of the factors that you look for to get maximum production?
Well, what we're looking for is first and foremost, we want to do a quality job. So
Right.
the quality comes before anything. But if we are getting that quality job, then we want to be as efficient as possible. So we're looking for the crew to always be efficient and make a quality box and make as many boxes as they can that fit our quality specifications. We also want that pack out. So the boxes come in, the plastic boxes come in from the field. Hopefully, if we pack one of those, we're going to get one of these as well, and so we don't have too much loss.
Right.
But, sometimes different fields will have more loss than other times, and that's just part of growing grapes and part of nature.
Yeah. Now, do you make daily decisions based on the numbers that you get, as far as maybe this field you start to pick it and it's not quite ripe yet and you have to wait a while?
We do.
Or as they go through the field, you can only pick certain amounts of the fruit and you have to go back and pick it later? Are all those decisions made on a daily basis?
Those are made on a daily basis. They are, and we want to we want to get the best color and the best sugar that we can and the best quality that we can. But if we don't have that, we'll move the crew to another field the next day, and so it's a daily thing that we're going through.
It really is data driven too, right? I mean, you have to make sure that the numbers are informing your decisions, because it is all about production at the end of the day. You want to make sure you have maximum production.
That's correct. And we're also we also, it's driven by orders also. So we may have needs for so many red grapes here, and then we pick green grapes, we'll pick black grapes. So we'll pick different varieties of grapes in the same day to fill different orders as well. So
now, compared to the middle of summer, because we know middle of summer is prime time grape season. Compared to middle of summer, with what you're packing now, are you packing half as many at the moment? Are you packing a little less than that, a little more than that?
Probably at this late stage in the year, I would say we're probably packing maybe 20% of what we would be doing in the summer.
So you really are wrapping it up.
We're really wrapping it up pretty fast. So.
And how much longer will you be packing?
Well, we'll actually be packing grapes for another month, but we're only going to be picking grapes for another less than a week.
Okay, gotcha. So the picking will end, the packing will continue, because they're going to come out of cold storage.
Right.
And there's so many different factors you have to consider, and all that data coming in each day is going to drive those decisions about whether or not to pack them, whether or not to hold them in cold storage for a while. And part of that has to do with the market too, right?
Right.
There's so many things we could talk about. We do need to go back and do some math, I think, in the studio, but when we come back, we'll talk a little bit more about where the numbers fit in to this equation, maybe see a couple different parts of your facility out here. So Mike, back to you in the studio.
All right, thanks for that, Scott. And I know where those grapes eventually end up, a lot of them right in my belly. You like grapes?
Yeah.
Do you have a preference, like red grapes, green grapes, purple ones, any?
Purple.
You like the purple ones? Those are pretty tasty too. Well, you know what? We do have a lot of math still to do. We'll go to the phones right now. And Caitlin, how are you this afternoon?
Good. How are you?
I'm wonderful myself. We've taken a look at your problem. We've drawn some of it up on the board. So read it to us one more time so that those at home can kind of follow along and see if they can figure it out. And then we'll kind of guide you on how to solve it. And then you can do that and then phone back with what you've got, okay?
Okay.
All right, so go ahead and read the problem.
The bus from Kevin's home to the middle school travels 8 miles west, then turns and travels 8 miles north, then turns and travels 7 miles west to arrive at school. If the bus were able to travel directly from Kevin's house to the middle school along a straight path, how much shorter would the trip be?
Okay, so what's your thoughts on how to set it up, how to solve it? What do you think?
So I first made a picture.
Uh-huh.
So does it look something like what's on the board right now?
I'm not watching right now.
Oh, okay. So you're going to have to pay real close attention then. So.
Okay, so go ahead. You made a picture. Hello? Are you there?
Yes.
Okay, so you made a picture, and then what did you think of your picture?
I labeled it with numbers.
Okay, so we did that here too. Are you
And
guys,
then-
are you learning Pythagorean theorem?
Yes.
Okay, because that's how I look at this and I see Pythagorean theorem. Okay, go ahead. So then,
I drew a line across.
okay. What'd you do with
So
your
I made-
numbers? Let's go to that. What'd you do with your numbers?
I added them all up,
Okay,
and I got 23 miles for the total distance.
okay, so that's the path right now. So how are we gonna figure out the path that it would be if it was straight to school?
I added 8 plus 7,
Okay,
so I got 15. So on the picture, the bottom was, I drew a right triangle.
yeah, exactly. That's what I have here too. And then you added to get the total across the bottom, which is 15. And then what's the side amount?
8
Okay.
times 8, so 64.
Okay, so you're already doing the 8 squared plus 15 squared. All right, 64 plus, what'd you get for 15 squared? Did you do 15 squared?
225.
Right. And then when you add that together,
I got 289.
okay. And then what's next? Take the square
I
root,
did the square root of it and
Uh-huh.
got 17.
right? And then you can go ahead and you just have to figure out how much shorter that is than the original 23.
So I did 23 minus 17.
Yep.
And that's how you can figure that out, right?
Yes.
Okay, so you're working with the square roots, and you were able to do that using the Pythagorean theorem.
Yes.
And you can see once you draw it out, it makes a little bit more sense. So hopefully that helps you out. And congratulations, you've got yourself a sandwich, courtesy of our friends at Chick-fil-A. Nicely done. All right, speaking of triangles, we're going to have you work on this triangle. So Cindy, go ahead and erase the board and just draw a large isosceles triangle. Here, I'll erase it for
I was
you.
like,
down.
I don't remember what, oh, the X, there it is.
There we go.
That's what I was
All right.
looking for.
So go ahead and draw your large isosceles triangle.
Do you know what isosceles means? Do you remember?
Is it all
And
are
label it
It's two of them are the same.
D at the top,
D?
D as in David.
Inside or the outside?
Wherever you like.
The name of it or whatever. Like
Down
the
on the
letter.
lower left is going to be E,
Okay. E,
and on the other side is F.
F.
The measure of angle D is 98 degrees.
So mine's not drawn to scale. I'm just gonna.
Right, and Haydn, you need to figure out what the other two angles are. And
So
I will
these
give
are-
you a minute.
Question mark.
Time starts
Question mark.
now.
Go.
Okay, so
So what do you know about triangles?
all angles equal 180.
Okay.
So
start with
it's
that.
172.
What do you gotta do? 98 though. You only did 8.
Yeah, 7.
Where are you getting 72 from, first of all?
98 minus 180.
So 180 minus 98.
70 minus 9.
If you're at 98, how many you need to get to 100?
2.
2. And how many you need to get from 100 to 180?
80.
So it's 82, not 72. That's why I was wondering where you were getting 72 from. There you go. Now go ahead and do it.
So 41.
All right, there you go. Nicely done. The degree symbol on there as well. Nicely done. Hey, we do have phone tutors available until 5:30. Right now, we're going to go back to the phones. And Maryam, how are you? Hello, Maryam.
Great today. Hi.
And because we've only got a couple of minutes, so as soon as you're ready, let's hear that problem.
Okay. 4 parentheses C plus 3 end parentheses minus parentheses C subtract 1 end parentheses equals 64.
I made it change. Okay, I have to learn how to use it. Okay, so what'd you do first, or what do you think you're supposed to do first?
You take the 4 from the very beginning and multiply it by C,
Okay.
and bring it down and make it 4C,
Okay.
and
What's
then
next?
take 4 and positive 3 and multiply it by each other and bring down positive 12.
All right.
And then I think you move on to the other set of parentheses and you multiply, well, in front of the parentheses I put a 1 since there was nothing there. So I multiplied negative 1 times C, which would be negative 1C. And then I took negative 1 times negative 1 and brought it down to be positive 1.
Okay.
And then I brought down the equal sign and put 64.
Okay. What's next then? Right so far.
And then you combine the like terms.
Okay, so what did you combine? Or
So
what will you combine if you didn't do it already?
I think you do 4C and you subtract it by negative 1C, which would be 3C, and then you take positive 12 and positive 1 and add them together to make 13. And then I brought down the equal sign and then put 64.
Okay.
And then you take 13 and subtract it from both sides of the equation.
Okay.
And then it would lead up to be 3C equals 51. And then you divide the 51 by 3, and that would end up being 17.
Okay.
All right, so Haydn, do you agree with that?
Yes.
It looks like everything was done correctly, right? All right, nicely done, Mary. You can check that by plugging 17 back into the original equation, making sure that everything works. And nicely done. You have just won yourself a couple of tickets to any athletics event at CSUB. Hey, we do have phone tutors available until 5:30 right now. We have one last opportunity to go check out on the farm and visit with Scott.
All right, we're back here at the packing house, and you can probably tell things got a little bit quieter. They've shut down the packing for the day, but agriculture never ends. Never ends. So they're getting ready for tomorrow. We want to talk a little bit about the math that goes into preparing for the next day so that they make sure that they're as productive as possible. So, can you tell us a little bit about exactly what we have on this page? Because this is some of that data we talked about earlier, right?
Yeah, so every day after we're done packing, we get a pack out and it tells us what exactly we packed that day, how many boxes of each. We have different types of boxes. So then after that, we plan for the next day. So if we were short on an order, we got to pack it the next day. If we're over, then we got to over inventory. So here's the pack out we have, where we pack, the hours, the packers, the helpers. And this all breaks down something for our boss, our owner.
Mm-hmm.
He figures how much it costs them to pack each box, how many yields he gets from each field. So it's all information. Here's the pack out, the percentage that he packed out that day, the loss.
So we have specific numbers that are definitely driving all those decisions. So can you just go down this column here? What are these numbers that are coming in, going out, all that fun stuff?
So coming in, these are the totes that come in that we use to pack that day.
All right.
These are the cartons of clamshells. These are Euros, which is a different pack style.
Okay.
So at the end of the day, we have 2091 that went in, 1851 that came out.
Right.
And the difference is 240 totes lost.
Okay.
But the totes are a different weight than the boxes.
Right.
So then that's where the percentage comes in at a different percentage.
Gotcha. So you didn't necessarily lose 240, but it gives you a number to work with, right?
Yeah.
And you can base your decisions for the next day.
Yeah.
Now, do you know what's coming in tomorrow? Like, what do you have to prepare for tomorrow?
Yeah. We always know at the end of the day what's
You
what's
gotta
going to
know,
happen the
right?
next day. Yeah.
Because you don't want to run out of all the packing material.
Yeah, we don't want to run out of boxes. That's,
Okay.
That's a killer out there.
Oh, I love it. I love it. Okay, so we want to know a little bit more about the math that goes in the day-to-day stuff. So we have some grapes right here. Alonzo's going to show us what we do with the grapes in the field. Tell us what you got here.
Oh, this is a digital refractometer.
Okay, that sounds awfully official.
All it does is measure the amount of sugar in the grapes, kind of gives us a ballpark figure of what we have here. And we basically just squeeze.
So right there in the field, you put a little grape juice in there, and it gives you a number.
Yeah, it gives you a number. So each degree of bricks is kind of, sorry about that.
You're all right. So while you're getting those numbers all ready to go, what is bricks? What is that number all about?
Well, each degree of bricks, 21.5, is equivalent to about 1 gram of sucrose.
Okay, gotcha. So we're talking sugar levels here.
Yeah, in a 100-gram solution. So obviously this isn't 100 grams, but it kind of gives us a ballpark number of how we measure sugar.
Yeah. And that's pretty important in grapes.
Yeah, if they're okay to pick.
Right.
Yeah.
Gotcha. So you can go in the field and see if grapes are ready to pick as far as being ripe or not, right? And not waste a whole bunch of time with a certain crew in the field.
Yes.
There's some numbers doing that. What number are you shooting for these specific grapes as far as the bricks
anything
level?
above 19.
Okay.
It's good.
Anything above 19.
And we're at 21 there.
And we're at 21. These are definitely good grapes. I have to take those ones home with me.
Oh, there you go. Have at it.
Good deal. Okay, so we have some numbers that come about right there in the field, right? And there's so many more things that we could look at. There's so many more other factors that go into farming. We could talk about fuel costs. We already talked about the packaging a little bit. We could talk about the amount of water that you do use. What about fertilizer? Does fertilizer and water affect the flavor of the grapes that we pick?
Sure. Fertilizers, I mean, nitrogen fertilizers, as an example, are used on almonds and a lot of other crops. You don't use a lot of nitrogen on grapes, so fertilization for different crops is very different. So depending on what crop you're growing, and chemical fertilizers and chemicals are all very expensive. So we don't really want to use things that are not necessary. We want to just give it the right amount and not any extra too, for different reasons.
So we want to make sure you can use those to get the best possible product, but not waste them at the same time, right? So many factors. So just because you might think about Farmer John on the farm with the pitchfork and the straw hat, there's a whole lot more numbers that go on here. Wade, we want to thank you for your time. Thanks for letting us come out here. We had a great time learning a little bit about how we pack the grapes, right? We have the famous do the math tile, so maybe we can get that up in the warehouse here somewhere. But thanks again for letting us come out. A little more math in the real world. We got to go ahead and wrap it up. Back to the studio there, Mike.
All right, thanks for that, Scott. And also thank you to Wade Kirschenman and Kirschenman Enterprises for allowing us to come out and visit the facility today and see a little bit more behind the scenes. We have phone tutors available until 5:30 this afternoon, and we have a new ambassador. Have you ever been an ambassador before?
No.
No? Well, you're an ambassador now. So this is your uniform. Do you have any idea what you have to do as an ambassador?
No.
No? All right, well, here's what you have to do. You have to wear your uniform every single day and tell people about Do the Math. Can you do that?
Yeah.
Both?
Maybe.
Maybe, yeah, there you go, right on, there you go. So as long as you tell some folks about Do the Math, we'll take that, and as long as you wear the Do the Math shirt every once in a while, that'll be good also. You good?
Yeah.
All right. Hey, you know what? Just one more reminder, no live programming next week due to the Thanksgiving holiday, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.